Hello students, this is Ioqm 2020 or PRMO plus RMO 2020 paper solution. This is the third part. So here we are starting from 7. Let ABCD is a triangle. Okay, and AB equal to AC. DB the midpoint of the segment BC. Okay. BD equal to 48 1 by 61, quite an unusual value, and DC equal to only 61. And EB the point on AD such that C is perpendicular to DE. This is done. So we need to find out AE. So right angle triangle, so CED. CE is root over 61 square minus 11 square, so 6172 into this 50, so 5 into 10, so this is 60. So ABCD is isosceles, so AF divide, so from that we can write BC equal to BF plus FC. So 48 1 by 61 plus 61 is 2BF. As FC equal to BF we can replace. So 48 1 by 61, this we can also write, so 2BF. So 109 1 by 61, so we can write 54 half and 22 only BF. Just taking this 2 lower, 54, and this is 31 by 61, that is equal to BF. So in the right angle triangle, now if we go to AFC, what we can see? So we can see AC square and 54 31 61 square plus AF square, simple Pythagorean theorem. This is equation 1. And in right angle triangle AEC, that is this one, sorry, I forgot to mention this. This is the F. Okay, AEC and AFC is AC square is 60 square plus AE square. So DF is BF minus BD. (41 minus 61), so 30 by 61, and this is 6. So in the right angle triangle AFD, if we proceed, AD square is AF plus DF. So AE plus ED square minus DF square is AF square. So AE square plus 11 square from this, (30 by 61 square is AF square. Now we have to insert a page. So equating 1 and 2 we get, so 54 square so 60 square, this will be equal to AE square. Solving, AE will be 25. So 25 is the answer. Next question is 8. So they have given a 9 has come. Let me just go to 8 again. A 5-digit number has digits k, k plus 1, k plus 2, 3k, and k plus 3 in that order from left to right. If the number is m square for some natural number m, then find the sum of the digits of m. So m square equal to 10 to the power 4 into k plus 10q. So in that way you can represent the number 10 square k plus 2, 10 into 3k plus k plus 3 separately. So you can take k common, 10 to the power 4, 10q, 10 square, 31, 1203. So this will give you 111, and this is, if you take this, so 20 will be added. Now for k equal to 3, n square equal to 3, 9, 333 plus 203, so 3, 4, 5, 9, 6. So m equal to the root over, so 1, 2, 4, so 1, 2, 4, 5, so 8 square, 6. So the sum of the digits 1 plus 8 plus 6 is pretty common every time. So after even the question, you have to make it a little bit tricky. So they ask the sum of the digits of the answer. Okay, so that's it for today. In the next video we'll solve from 9.